Today I'm going to be unboxing and reviewing this Sprite Extruder Pro Kit and installing it on my Ender 2 Pro to upgrade this to what I'm going to call the Ender 2 S1 Pro. You can install this kit on virtually any printer and it'll give you a nice direct drive extruder and an all-metal hot end. So let's take it out of the box. What can I do if the fan shroud broken when arrived? It seems like they have an issue here with not having enough packaging, but whatever, let's keep going. CR Touch installation guide and an instruction manual. Alright, and here's the real meat and potatoes. So we've got the Sprite Pro hot end. This actually sticks up out of the box a little bit. It's getting unnecessarily stressed during shipping. Also, there's no padding on this top wall. They put a nice layer of foam all the way around it, but they're forgetting that this is one of the surfaces that could be impacted. So, I mean, they really should have put a piece of foam up here. And let's take it out of the box. And here's the Sprite Pro extruder hot end combo. It looks pretty good, but I'm sure there's some small upgrades we could fit on here to make it work even a little better. Then on the right side of this compartment we have this cable here, a carriage with wheels on it. This gets attached to the X gantry on your 3D printer, so that fits on right over here. Then it looks like we've got a couple fasteners, a spare nozzle, and a small CR Touch connection cable. Notably missing from this box is the actual CR Touch automatic bed leveling sensor. There's just a missing spot where you're supposed to install that yourself. This thing costs over $100 and they don't even provide the bed leveling sensor, which I think is being a bit cheap. They want you to pay an extra $30 just to get bed leveling on this hot end. I completely reverse engineered and redesigned this breakout board. You can check these out in some of my other videos. In that process, I gained a deep understanding of how the wiring and circuitry works on the Ender 3 S1. So that makes me well qualified to analyze this cable and look for any safety issues or design flaws. In the user manual, they have a simplified schematic of this hot end. This isn't exactly how it's wired up. If we want to learn anything about this cable, I'm going to have to probe it myself and figure out how they made these connections. I'm also going to open up this printer so that I can cross-reference how it's plugged into here and how it's plugged into the hot end. Okay, so our extruder motor gets plugged in right there. That's pretty straightforward. Since we're switching to a direct drive extruder instead of the Bowden tube extruder, we're just going to unplug that old Bowden tube setup. We'll also be unscrewing the heater cartridge and this non-controlled fan. This is where it gets a little tricky because you can see they've spliced multiple wires into this terminal block. That's a pretty bad practice. We don't like to do that in electrical design because it makes it harder to service and understand wiring schematics. I'll also be unplugging the thermistor for the hot end. I'm just going to peel away some of this hot glue and unplug this thermistor. So then the tricky thing is that all of these wires are kind of tied together. We've got a bunch of zip ties that I need to cut here just so that I can free up those wires that I no longer need. This connector goes to the part cooling fan, so I'll go ahead and remove that as well. So here's all the wires that should be going to the hot end, and I'm going to be taking all of these out. They all go into the same cable protector that is shared with a bunch of these other components, so I'm going to have to kind of take this all apart and fish that out. Also, there's not really any mention of what to do with this grounding wire, but what I'll try to do is just leave this in place and then try to attach it somewhere to the Sprite hot end. So let's just fish these wires out. I'm going to take the filament spool off for now, and we'll see which of these wires we can tease out of this bundle. I think I'm going to have to undo all of these zip ties all the way up to the hot end. Also, I'm going to remove this extruder. We don't need it anymore, so let's just get it out of the way. You have to completely disassemble it to take it off. This is just what you have to deal with when you own a Creality printer. This disassembly process is way overcomplicated, but fortunately we don't have to deal with disassembly ever again once we're done with this mod. Time to start disassembling it from this side. We have to remove this fan shroud. This whole hot end is going away, as well as this fan. I guess I can just take this whole carriage off while I'm at it. I'm really tempted to take these wire cutters and just cut everything off right here, but I gotta be smart about this, and I want to leave this somewhat intact in case I need it later. I wonder if I can just do this. So, unscrew this all the way, take off the belt here, pull this out. Oh, this is already broken. Crap. This is a really flimsy design. You can see this hole is right up next to the edge here where it can easily just be pulled out. So I'll detach the belt and now everything's good to go. I'll just roll it off the end here. And the only thing I'm going to be keeping is this ground strap. So let me unscrew that. Then I'm going to cut this last zip tie. And when I pull this off, I should be pulling all of the wires with me that need to go. I'll just be leaving this ground strap behind. Ta-da! Now I've got this mess of wires and stuff that I don't need anymore. Also, I don't need this extruder stepper motor cable anymore, so I'm going to go ahead and pull that out as well. So with all of those old wires out, we've got somewhat of a blank slate here. The one thing I'm going to correct before we keep going is I'm going to install crimped ferrule ends on this heated bed cable and also on the wires that feed the main power to the 3D printer. I think they include the screwdriver with the Ender 2 Pro, so I'm going to use it for these last little bits. Now when you're pulling these cables out, remember which end is positive and negative for the power supply. It really matters because if you do this wrong, it's not going to be good for your printer. We'll put it that way. So it looks like they soldered these ends here. I'm just going to cut that off and strip some of the wire. And then I'm going to install one of these ferrule ends. Now it's best practice to get rid of the solder on those wires. If it heats up, it'll start to get weaker and it'll creep, and basically that means it'll change shape and it'll make it easier to pull out. We want to avoid that happening because that's one of the ways you can start a fire with electrical devices. So I'm just cutting off these old tinned ends. So now these should be much safer and more durable. I'm going to plug these back in. Then I'll retighten those terminals. Now I'm going to do the same thing for the heated bed. Then we'll just plug these back in. Sometimes it's a little tricky to fit your hands in there, and that's when it's good to have a nice pair of needle nose pliers. Alright, so that's looking pretty good. Even if you're not going to be doing a bunch of mods to your Ender 2 Pro, if you have the electronics experience, it's worth going in and putting these ferrule ends in because it's reducing the risk of a fire hazard. Now, if you go in there and you mess things up, then it could be increasing the risk. So you just got to keep in mind your experience level and how comfortable you are with being able to do this correctly. So I've changed my mind a bit. I've decided I'm not going to use this ground strap. We're just going to pull that all the way out. And I'm not going to reuse this bit of wire wrapping. I'm just going to feed the entire hot end cable through here, and that will kind of keep all these wires in a bundle with the stuff that's going to the x-axis. I'm just going to tape all these connectors up so they can fit through the wire protector a little more easily. So I'm just going to kind of shove it in the top here, and all the wires come out on the other side. Now I'll just get rid of that tape. So the interesting thing about the way they did this wiring harness is that I know that these 4 wires go to the positive terminal of the hot end, and these 4 wires go to the negative terminal of the hot end on the Ender 3S1. But on this wiring harness, they've branched off some of these positive and negative leads to other things. It just seems really messy and convoluted. Also, we've got this 2-pin connector, which is just shorted together at the other end of the cable. So if you plug this into anything important, it's going to fry your board. And you've got this 3-pin connector. This is essentially the ground pin on the Ender 3S1. But for some reason, it's a 3-pin thing over here. So these 3 pins are shorted together, and if you plug this into anything that could potentially plug into, it'll fry your board because it's just shorting all of those together. So there's a lot of mistakes that are really easy to make with this kit. Basically, all you need to know is you don't want to plug this connector into anything, and you don't want to plug this connector into anything. Otherwise, there's a high likelihood that it's going to fry your main board. So I don't know why they put a plug on these ends, because really they just don't want you to use them at all. So I think it would have been better if they just trimmed them and put some kind of thing that couldn't actually plug into stuff. I think that's just a really bad decision on Creality's part. You just got to be careful when you use these things. People aren't going to understand how this board works, and they might just be plugging things in and trying things out. But no, you definitely have to know what you're plugging in when you plug it in, otherwise you're going to fry stuff. I think that's indicative of a really poor design philosophy. If you make it really easy to make mistakes, people are going to make mistakes and things are going to break. So I don't know. I can't say I'm surprised that Creality is designing things this poorly, because every indication that we've gotten so far has told us that yeah, you really can't trust Creality to do things correctly. The other thing that's really bad here, if I don't plug in both of these pins for the heater, like if I just plug in the positive pin, there's a chance that it'll send all of the electricity from the heater block through this positive pin, and it's going to have a return path that goes through well, I don't know. Basically, this wiring is a convoluted mess. All you gotta remember is you definitely don't want to plug these two unlabeled things into anything. Otherwise, there's a high likelihood that you're gonna fry your main board. So let's get back to putting this thing together. One thing that I grabbed off of the old wiring harness was this. I'm gonna splice this little thing that's used to power the motherboard fan onto my fan positive and fan negative connections. This isn't a great way to do it, but this is how I'm gonna do it. Basically, I'm just going to cut these two wires, strip them back a little bit, then I'm going to twist them together and put one of these crimped ferrule ends on the pair of wires. And I'll do the same thing with the fan positive cable. Twist them together and crimp a ferrule end on them. And I'm going to trim these back just a little bit. And by trimming those back a tiny bit, they'll fit more flushly into that connection. I'm also going to trim my heat positive and heat negative just a little bit. I'm only cutting about 1 millimeter off. I forgot which one was positive and negative for my fans, but fortunately it shows you on here. You can see there's a fan positive and fan negative. So you're just going to want to plug your wires in accordingly. And if you look over here, there's the heat positive and heat negative. One thing that you really need to know here is normally heater blocks can be plugged in with the positive and negative reverse, because it's a simple resistive element, meaning that there's no definite positive and negative. But with this kit, it's extremely important that you follow which end gets plugged into positive and which end gets plugged into negative, because they're making all sorts of assumptions about this being positive and that being negative, and it's just a really bad design because you're taking something that's inherently simple and making it more complex and making it easier to make a mistake that can fry and damage things. With that rant out of the way, I can start plugging everything in here, being extra careful to follow the labels for positive and negative. Plug in the CR Touch cable. If I ever want to add a CR Touch to my hot end, I'll be able to do it by just plugging it in up at the breakout board. I'll plug in the extruder motor here. Oh man, I can't believe this. I think Creality used some knockoff connectors here because these don't actually fit into the plugs. Oh man. So I've got my calipers here and I'm going to measure some stuff. So if we look at the stepper motor that we just unplugged, it's 4 millimeters if we measure across the tops of those little keying features. If we look at what we get in the replacement cable, you can see this is 4.8 millimeters. So just take a look at these side by side and see if you can spot a difference. Oh wow. Also, this is a 5-pin connector versus this is a 4-pin connector. So I've decided what I'm going to do is just cut the old extruder cable. Then I'll split these wires up into a 4-pin connector that can be plugged into this new cable setup. I made a little breakout board for the stepper motor driver. Basically, we go from the 5-pin connector here up to these terminal blocks, and then that goes to this 4-pin connector. So it's a nice little adapter, and I can change the sequence of these wires if I need to. I built this little breakout board using solder bridges, so I just connected the appropriate pins together using blobs of solder. The tricky part about doing this is making these connections without accidentally having the blobs run over into each other. I'm going to wrap this in a little bit of tape. Alright, next up let's plug in the K fan. That's for the variable speed fan that powers the part cooling. Now I gotta pay attention here. Positive and negative are very important to get right. We have the positive that needs to go on the top. Negative goes down here. Heat positive goes here. And heat negative goes down here. These wires for the heaters are pretty skimpy. I would really prefer to have thicker wires for that. I'm pretty sure it'll be okay, but when you're carrying high current, basically anything over 0.5 amp is what I would consider high current, you want your wires to be really beefy and overkill, because if the wires get damaged or pinched, you might lose some of the conductors in there. Too much current passing through too small of a wire, well, that can start a fire. Alright, this is for the thermistor for the hot end. That goes down here. I was talking about these dead-end connectors before when I plug the other end into Creality's own breakout board and I probe these pins. There's a short between these two pins and there's a short between these two pins. If I were to plug this 2-pin connector in to this fan port over here, it would fry my motherboard. If I plugged it into this fan connector up here, that would also fry my motherboard. So this is just stupid engineering on Creality's part. If you're just kind of fumbling along putting this together and you plug these into the wrong places, you can break your motherboard. Also, I can't read any legible text on this board telling me what any of these plugs do, and it's really easy to make mistakes when things are this ambiguous. Toyota engineers came up with a term called poka-yoke, and that refers to the practice of designing an assembly so that it can't be put together incorrectly. You can imagine these are automotive engineers. They need to build millions of cars, which are very complex devices. You want your assembly line workers to not be able to plug things in incorrectly. So by providing people the opportunity to plug this in and fry their board, I think that's kind of stupid on Creality's part. You want to go on the couch? You want to go on the couch? This is a very polite dog. She always asks permission to get on the couch. I think she just kind of likes watching me do 3D printer mods. She's making direct eye contact with the camera. This is kind of weird. Okay. All right, that's enough of that, doggy. So I'm actually going to cut 2 of these wires off and hook them up to this ground pin here. So I'll just pull out this one that originally went out to the hot end, and instead I'm going to try and hook up these wires over here. So I'm just going to screw this in, and it's going to pinch these frayed wires. But based on my understanding of this circuit, I think I should be attaching this to ground. Don't quote me on that, though. Alright, at this point, I think everything should be wired up. The only thing left to plug in is this motherboard fan when I put it back together. So I'm going to go ahead and do some wire management here. We'll break out the zip ties and get this thing all tidied up. One nice thing about this printer is it's so small you can just set it in your lap and start working on it. So I have great access to all these wires here, and I don't have to hunch over or look at odd angles to be able to reach things. This build had a bunch of extra cable length because this Ender 3S1 mod is designed to fit on even larger printers. And this is a tiny printer, so I didn't need nearly as much cable length. But I tucked most of it away right here, and I'll see if I can squish this plate back onto the printer. Make sure I don't have any stray wires that come up and block the fan. It barely wants to fit on there, but if we can get these screws in place, we're going to call it mission accomplished. And see if the fan still spins. It still spins, so we're in business. Well, it looks like I didn't leave quite enough cable hanging out here, so we'll see if I can pull some through without destroying everything. Well, let's hope that worked. I got my cables all to the right length, so this can move all the way back and forth. Next step, I need to put this carriage on, and I just need to loosen up this eccentric nut a little bit. So now it's at just the right amount of tension. It can move back and forth. And we can attach the hot end up here. And we'll attach the belt onto this carriage. We saw our first little flickers of light down there. That means I might have wired this up correctly, but we'll find out soon enough. So I'll loop this around here. Now I just have to screw this on to get the right belt tension. And we're good. Let's see if this 3D printer can turn on after all these crazy mods. I think there's about a 50-50 chance that I broke something. Here's the moment of truth. Will it work? Well, I'll be darned. It looks like it's going to work. I want to switch from this refrigerator magnet type of print surface to a PEI print surface. Spring steel is one of the toughest materials known to man. I have some grip tape here. I'll just stick it onto this metal base, and then I can just sand away. That really dulls down these sharp edges, so you can see I went from this, which could easily cut you, to this nice rounded edge. I'm also going to sand down these edges a little bit, and I noticed that a couple of these corners are slightly bent, so I'm going to go ahead and unbend them. So here's my unbending tool. I'm just going to go ahead and tweak this by eye until I can get it straight. I want to touch all four corners and see that the bed isn't moving when I do it. And that looks good to me, so we're all done. Well, that part of the mod was easier than I was expecting. I had to move it up a full rat's whisker. This hot end fan is really loud and annoying. We'll try fixing that later. I'm just going to loop the filament up through here and then down into the hot end. Alright, I know I need to update this configuration file and change the E steps per millimeter to 420 something. We'll store settings. Hot end is heating up. That all looks good. I don't know what's going on here, but this part cooling fan was actually pretty quiet. Our hot end is up to temperature. Let's see if it can extrude plastic. Plastic is coming out. Pardon the noise, the dog's having some nightmares in the background. It's okay, doggy. Everything's gonna be alright. Oh no. She's crying. Well, more important things are going on over here. We got our first print going, so let's see how this is shaping up. Oh, the extruder's turning backwards. I should have known. I gotta switch some of the wiring things around. Let's see. I left the breakout board exposed. That helps me determine my stepper motor polarity. So I'll just access that. Switching all this around should be quite simple. I think if I was smarter, there's probably a way to change the direction that's a little bit easier than this. But the way that I know how to do it is to just reverse the direction of all the pins. So flip these ones on the left with the ones on the right. I'll come up with a better long-term solution later, but for now I'm just gonna put it in this little plastic bag. That seems pretty safe. And then we'll cover it up with this screen. Nobody will see it. There we go. Alright, let's see how this thing prints. Go, printer, go. This first layer might look kind of bad because I was adjusting the bed level as it was printing, but it looks like it's going down pretty well now. I really like this. Our first print came out looking really good. I'm running a few more prints and then I'll try out some PETG. Alright, here's a couple more structural parts that I just made. And these prints look really nice. Let's take a close look at the print quality here. You can see here's the bunnies. I haven't touched them up at all. You can see there's some little dots there. That's from the crappy filament that I'm using. I got it for free, so I can't complain. If you look at the bunny's face, that's an area where there wasn't really that many little air bubbles. So you can see super consistent layers. And here's the bunny that was printed on the original Bowden setup. This was with drier filament, so you don't see those little bubbles. Super impressive print quality for a machine that's that cheap. Now let's look at some of the mechanical parts that I printed. Here you can see the Z seam. I don't know why Prusa Slicer decided to put the Z seam there. That's kind of a terrible spot for it, but whatever. Up here there's a little bit of issues. Looks like also has to do with the Z seams. I need to figure out how to get better at slicing things. Hitting it with the angled light holds up really well. On the inside there's the slightest bit of stringing. On this side you can't really see it as much. But overall, very good print quality. One small area where you can see a difference is right here. After the eyeball is finished, you see there's very little ringing on this Bowden setup. But over here on the much heavier direct drive setup, you can see there's a little bit more ringing. So that's just a slight artifact right outside of the eye where it changes directions abruptly. And I didn't clean that stringing up at all, so what you see is what came directly off the printer. Then here's one last angle of the bunnies. Get some harsh angle lighting on there. Overall, very consistent prints. I've got my PETG print started up. I'll be taking this printer to even more extreme levels in my next modding video. Now, one complaint people had about the Ender 3S1 is that it's kind of hard to see what you're printing, but that's completely solved on this printer. With this machine, you can just get down to this angle and you can see pretty well what's going on inside of the print zone. Normally on an Ender 3, you'd be blocked from being able to see from this direction because there's that second support here, but since we're completely missing that on this machine, we have this nice angle that we can see everything. All I need is a little bit of light in there so that I can see what's going on a little bit better. So this is my Ender 2 S1 Pro. I've had a lot of fun building it. I'm not a huge fan of the way Creality did this wiring harness because, in my opinion, they took some shortcuts with the wiring that they shouldn't have taken. And there's almost limitless ways of you to plug this thing in incorrectly and fry your 3D printer. But as long as you're being careful, I think you'll be fine. So in case you are wondering, that's how you install a Sprite hot end onto an Ender 2 Pro. I know there's a couple things missing, like this CR touch and some lights. We'll see what we can do in some future modding videos. I know one thing I want to take care of is this fan. Just take a listen here. That's the hot end heatsink fan. It's super loud, unnecessarily loud if you ask me. And listen to it when I stop spinning it. The printer becomes super quiet when that's... What do you want? What? So that's definitely something I'm going to be tackling in my future videos. Overall, I don't know if I can recommend this mod to anybody. I mean, after all, this Sprite extruder costs about what I paid for this entire 3D printer, and you don't really get that great of a print quality increase. You just kind of get the style points of having a Ender 3S1 looking hot end, and you know, it's direct drive, so there's some advantages with that. I think this thing is pretty well tuned with just that Bowden setup. Actually, I think the main advantage here is one that I haven't really explored yet, and that's with a direct drive setup like this, I'll be able to get extremely high volumetric flow rates. If I put a CHT nozzle on here, I think I can get about 25 cubic millimeters per second, which is about 5 times what you'd be able to get out of a Bowden tube setup. So this thing will be super fast, but I think I'm going to have to save some of those mods for the next video because I've already spent enough time tinkering around with this thing, and I think it's in a pretty good state right now. I mean, I could just leave it like this and I'd be really happy with this machine. Thanks for watching this video. Make sure to subscribe so you catch my future Ender 2 Pro content, and I'll see you in the next video.